taking a look at rational expressions to figure out the first derivative test, we need to look for critical numbers. However, there's a little hiccup. Critical numbers work when I have a continuous function, but if I look at f of x, I notice I have a vertical asymptote, so it's not continuous. So here's how we work around that. We're just going to make a note that the domain means that x can't be 0 because I know I have a vertical asymptote at that location. So I'm just going to keep that in mind for the rest of the problem, okay? Any other x value we could plug in. So aside from that, this function is continuous. So if we look for its derivative, f prime of x would be low d high minus high d low over low low. So then from there, we try to simplify the numerator. So we got 3x cubed minus x cubed minus 2. Careful when you have to distribute that negative for what you're subtracting, over x squared means that we end up with 2x cubed minus 2 over x squared. Okay. So now, based off this function, we need to go ahead and find our critical numbers. And remember, critical numbers are values where your where your derivative is undefined or where your derivative is equal to 0. Since you have a rational expression, I need to look to see where the numerator will equal 0, because that'll tell me where my derivative would equal 0. And I need to find where my derivative, or where the denominator of my derivative would be equal to 0, because that's where my derivative would be undefined. Okay? So take the top 4 equal to 0. So f prime of x will equal 0 if 2x cubed minus 2 is equal to 0. So that means 2x cubed has to equal 2, meaning x cubed should equal 1, meaning x should equal 1. So that's one of my critical numbers. Now, if we look at the denominator, let's give ourselves a little more room. The derivative will be undefined if the denominator is equal to 0. Okay, but here's something important to begin with. Remember, the critical numbers work if the function is continuous. Our function was not continuous, and here's where we run into like a little dilemma. Technically, this value of x is outside the domain. So I'm still going to do my number line stuff that I typically do, and I'm going to evaluate it, but I have to note that I have an asymptote there that was outside my domain, so I wouldn't count that as a critical number. But I'm still going to use it for testing purposes, and hopefully you'll see like what happens there. So let's go ahead, and I'm going to erase a little bit because I need more room. So to summarize, we have our derivative equal to this thing in the yellow. We have it equal to 2x cubed minus 2 over x squared. And I know my critical numbers, well, technically my only critical number is 1, but I also have to talk about what happens when x is equal to 0. So I need to put 0 and 1 on my number line. Take us home. So based off that number line, 0 and 1, my derivative value is 0. That's why I put the little 0 up top to also make sure it's not included. And up here I have a undefined like asymptote. It's outside, so I would maybe even make it a little dotted kind of line to distinguish that value. Okay. So let's do a little testing. I'm going to say -1. If I plug a -1 into my derivative, right, f prime of -1 would give me, I'm going to have a negative number in my numerator over a positive number in my denominator, so overall my answer will be negative. Kind of expected it. Okay. I'm going to go ahead and test out another value. Let's say 1/2. Positive 1/2. Okay. So f prime of 1/2. All right. If I have 1/2 raised to the third power, that should be 1/8. 1/8 times 2 is not even going to be 1. So I'm going to have a number less than 1 minus 2. I'm going to have a negative number up top. A half squared, anything squared is automatically positive. Interesting. All right. And let's test out something greater than 1. So let's say f prime of 2. So 2 times 2 to the third is going to be something bigger than, is going to be like 16. 16 minus 2 will be a positive number divided by a positive. So that's going to be positive right there. Okay. So now based off my work, I'm ready to summarize some of my conclusions in terms of the intervals that are increasing, decreasing, as well as the extremas that I have. So here's what we have. From -infinity to 0, or from 0 to 1, f of x is decreasing because I have my derivative produce negative outputs when I tested those intervals. And I can also say that from 1 to positive infinity, f of x is increasing. Right? And as a result of my extensive testing, I'm going to figure out what f of 1 actually is. So f of 1 would be 1 cubed plus 2 over 1. So 1 plus 2 is 3. 3 divided by 1 is 3. So 1 comma 3 is a. So I'm going from decreasing to increasing, so it should be a relative minimum. And that's it. Notice how I can figure out the relative minimum if I kind of visualize how the graph is going to look. So that's why I'm saying, like, it's decreasing from the left, it bottoms out, and then it starts to increase again. So it could look something like that. That's how I know it's a minimum.